Advances in silicon based computing have driven innovation in recent decades. However, modern workloads, including massive projects like climate simulations and AI training, are pushing high performance computers to their breaking point. Hello, everyone. Welcome to the Analytics Insight podcast, where we talk about the ever evolving tech space. And I'm your host, Priya Dayalani. While quantum computing can be called as a solution for such a challenge that we are facing, it is still in its early stages, years away from supporting commercial scale applications. Into this gap steps a promising contender, photonic or optical computing. In fact, Gartner just included photonic computing in its 2025 hype cycle for data center infrastructure technologies, a key indicator that the technology is gaining traction among industry leaders and investors. Let's welcome Dr. Rohin, founder at LightSpeed Photonics, to share his insights on AI driven computing and next generation photonics. Hi, Rohan. A very warm welcome to our podcast today.
Thank you so much. A pleasure to be here.
Likewise, Rohin. And to be honest, when we talk about photonic or optical computing, I really have, a zero idea about this new technology that is helping us tackle the computing challenge that we are facing today. I'm sure our listeners and I would be really glad to unlock more insights around this from you, and our conversation would be surrounding this technology today. But before that, I would like to set the foundation for today's conversation by telling our listeners about Lightspeed Photonics, its specialization, and alongside that, a little bit more about you, Rohin. How has the journey been till date, and what led you to found Lightspeed Photonics?
Well, we have actually started seeing the symptoms of these problems almost 6, 7 years ago. And now that the time has come for the applications, most people started recognizing it. But overall, when people say photonics, I think they may not recognize it immediately. But when we say fiber, instantly recognize it with something like Geo Fiber or Airtel Fiber in India, or basically fiber to home is what people know to be the fastest because light is the fastest there is. So hence the name light speed photonics. Literally you can transfer data at the speed of light, and that is the only means to communicate huge amount of data that is required in the future of data centers or anything. And when we saw all this AI compute was going to be having a critical bottleneck in the way they share data between them, because none of the future problems are a single chip problem anymore. And any simple thing that you are trying to solve, whether it is a chat GPT query or a recommendation engine on YouTube or Netflix, all of those are running on complex and huge data sets that require inherently all these GPUs and other processors to share data between them at such high bandwidths that they can only deliver this data rates when in milliseconds, microseconds of computational time. So that is where we saw the opportunity. And for us, the journey started with this clear insight that future AI and high performance computing systems need high bandwidth connectivity, but also you have to make it extremely compact in its footprint. And I'll talk further on why small footprint is an important one in data centers, and low power. And it's kind of a no brainer when you talk about data center power consumption, but networking is becoming a big power guzzler. And that is also something that we need to address going forward. And these are the things that we started back in 2020. And we realized optical computing may not be the right starting point for most of the data center applications today. And we quickly pivoted our journey to focus on optical communication. But within that, where we played specific, identified the specific niche, and also categorized ourselves, has given us what we have as an international visibility, and also the credentials that we carry across among our customers.
Thank you for that insightful introduction, Rohin. And we are really glad to understand about Lightspeed Photonics, its vision that drives its growth. And we're really glad to see the overall contribution of yours in shaping its direction and creating value for customers and the industry at large. With that foundation set in place, let's discuss about the macro landscape of AI today. AI is getting all the headlines, definitely, but IT infrastructure is where the real pressure is building because across industries, organizations are discovering the traditional storage architectures built around silos or rigid scaling, so simply can't keep up with the modern data demands. Why is AI forcing the industry to rethink the fundamentals of computing and data infrastructure?
It's a very critical question to answer because originally data centers were just that, data centers. They're basically just storing data. And it was a huge set of infrastructure that was put together to store data and cater to people over the internet, right? And that required only a minimal management of data across. Yes, it has gotten more and more complex with what they used to call in 2010s as big data analytics, and the big data analytics inherently needed some pattern recognition algorithms, which included machine learning algorithms, and then that graduated into what we know as AI and AI infrastructure today. So, AI infrastructure, by definition, had to reinvent the hardware in a way that can focus more on computing the data at a huge scale rather than just store and develop fewer insights from it. So, what shifted was, of course, the general purpose GPU computing, as we call it. CPUs are sequential in nature, so they basically process data one bit, one byte at a time, one
Right.
instruction at a time. Whereas GPUs can handle data in a much more parallel manner. So massively parallel amounts of data streams have to be shared across these GPUs. And this is one of the key reasons why the interconnect started becoming a quick bottleneck. And it's not surprising that the NVIDIA took the lead in this for compute, but AMD, Intel, and many others who will be taking prominent roles in this market have a strong say in the way the future infrastructure gets built. But the interconnect as a bottleneck is something that is, again, I figured from the early days of my physics research also that this individually infrastructure is okay to compute very fast. So if you have a state of the art GPU, it can do really fast computations. But how quickly can that computation be shared with other GPUs in the network is where the bottleneck started coming. And with huge data sets that needed to be processed, we have huge videos, huge set of data that needs exchange. And that's when the interconnect started becoming a bottleneck. And you'll be probably surprised to know that the networking power consumption is also rising so much to 20-25% of the overall data consumption, and some AI data centers were estimating that the interconnect power can go as high as 40%. And now that is where the infrastructure has
Right.
given a lot more focus to photonics than traditional semiconductors and the industry that is surrounding it.
Hmm. Yeah, true. I mean, Rohin, your response really highlights how AI isn't just another application running on existing systems. It's fundamentally changing the way we think about computing itself. Of course, and today's AI workloads demand an entirely different approach to infrastructure because here we are talking about massive volumes of data, real time processing, high performance compute, accelerated networking, and storage systems that can keep pace only when you have those increasingly sophisticated models. So traditional architectures that were designed for conventional enterprise applications are now being pushed to their limits. Great. So coming back to our discussion around photonics, Brohin, of course, we discussed about the challenges the current AI industry is facing in terms of the increased compute power that we need to meet the successful running of AI models and applications. How do you think this photonics can, make AI computing both faster and also make it more energy efficient?
Yeah, that's a good question. So, if you think from what we were discussing, how the data should be exchanged and networking power growing higher, you have to also see historically, the industry faced what we used to call as a compute wall, meaning that we were not able to process data fast enough. And obviously, that is the thing that general purpose GPU computing solved in a major way, that they were able to compute fast. And we went beyond the compute wall, and then we hit what we call as memory wall, meaning that how much, because your computer has gotten so fast, now how much memory can feed that compute engine. And so the memory wall was becoming prominent, and the memory companies addressed it with some new technologies like what we call as high bandwidth memory. And then there was a lot of advanced packaging in semiconductors that had come in to integrate these memories inside the chips package itself. And now the industry has moved to what we call as the interconnect wall. Why? Because the problems have gotten so big, and the processors have to exchange information beyond the chips package on the motherboards. Now they have to network across themselves to such high bandwidths. It's almost as if all of these chips are on the same board or on the same chip even. So that is where the interconnect bottleneck can only be solved with photonics, because as we already established, electronics is a slower medium, but it is the most efficient one when it comes to compute in the shortest of the distances. But the moment the distance goes little further, and for high bandwidth, farther the distance, quicker the decay of the data happens. So basically, your signal will die down very fast. Wi-Fi going down very fast versus a mobile signal that can go farther, but it'll be lower bandwidth. The conversion to photonics, that is light, has to happen faster. It has to happen closer to the compute. And that's where the photonics has emerged as a new technology to
Hmm.
enable faster AI computing, because you need to be able to share data between the processors. And how do we make this more efficient? Because the per bit data transfer, you need to be able to reduce the power consumption to such minuscule levels that you will be able to pump out huge amount of data without losing in so much. So basically, energy efficient, yes, it has to be. The best way to do it is to put it closest. And this is one of the technologies we call as near packaged optics. This is what Lightspeed pioneered in. There is also something that are here to stay to bring photonics integration into the next generation electronic systems and computes.
Right, right. Thank you for that perspective and highlighting the importance of photonics and why it is attracting so much attention in the AI ecosystem. And what's particularly exciting that photonics has the potential to fundamentally change the way AI systems process and move data, making high performance compute not only faster but also very much sustainable. And I think this could have far reaching implications from hyperscale data centers and cloud infrastructure to edge AI applications where energy efficiency is absolutely critical. And it feels like we are at the beginning of a major tech shift where advances in hardware could redefine what's possible with AI over the next decade. Great. Now, Rohin, when we talk about photonics, traditional copper interconnects are now encountering bandwidth and efficiency limitations, especially beyond 200 G per lane. And optical connectivity offers a more scalable alternative because light-based communication can transmit larger volumes of data with lower energy consumption. And this growing demand for optical networking is encouraging semiconductor companies to invest heavily in photonics platforms, integrated optical chips, and advanced manufacturing ecosystems. So, what is silicon photonics? And again, why it is emerging as a key tech for high-speed AI data transfer?
So this is a very interesting trend. Overall, in silicon, we know how to scale. We know how to produce in such huge volumes. it's literally the cheapest thing you can buy, right? The transistor is what when it was invented, a few dollars novelty to its nano paisa today, right? It's the cheapest thing available in the universe, right? You can literally buy those transistors. So you know how to scale with silicon. We have all the foundries and the fabs. So the when silicon photonics investment started, the key goal was to be able to build on top of the infrastructure that knows how to scale up silicon-based wafers to compute chips to use it for photonics. And as would have it, probably that was a coincidence that one of the long wavelength ranges happens to be transparent for silicon. So basically, you can etch waveguides, kind of think of it like light pipes inside silicon, and they can transfer light within, just like wires would conduct electricity at a certain wavelength of optics that can also take it to farther distances. So silicon photonics actually garnered a lot of interest. But having all the good things about this, there's still a lot of challenges around, which is where we have identified some alternative frugal methods to do what we call as heterogeneous integration. Because what happens at the end of the day, you cannot make a laser in silicon, and you cannot make photodetectors that are very fast in silicon. And so the photonics needs are very different from what traditional compute requirements are. So silicon photonics, while having all this goodness, needs external what we call as 3-5 elements, 3-5 semiconductors that makes it fast. So silicon to 3-5 materials, the interface is what is heterogeneous, and when you integrate them together, that's what you can build the future photonic systems around. So almost all the needs are centered around that, and we've identified that niche, and that is actually an emergent technology for the high speed AI data transfers, because it can be closely integrated with silicon. It has almost all the similar properties, and we make it very easy to integrate, whether it is at the board level or at the chip package level. And those are some of the key drivers that are enabling this ecosystem in a much larger way. So I think it is just beginning. The adoption wave we are yet to see, and the key thing that the companies like us are working on are on production readiness. So basically, the biggest challenges in silicon photonics today that needs to be addressed are around manufacturability and yield. And of course, once you are able to manufacture with good yield and throughput, you will be able to also reduce the cost overall. So those are things that make it very interesting for the industry overall, because the first ones to solve these problems are the ones who will win big. And that's something that makes it very timely, that is ripe for adoption in terms of the application use cases for AI. And at the same time, you have interesting challenges that give startups like us a lot of playground in which we can create newer solutions for the next generation.
That's really insightful, Rohan, because I think we always often hear about GPU and AI accelerators driving the AI revolution. But what's equally important is that the is a network that connects them all. As AI workloads become increasingly data intensive, ensuring information moves seamless between thousands of processors has becoming a defining challenge for modern infrastructure. And then now with the entrance of silicon photonics, I think it could make this possible. And building these next generation interconnects this without its own hurdles. Now, this of course provides a smooth bridge while educating listeners before moving to the next question. Now, my next question is somewhere understanding your perspectives around the position or How India is positioned in terms of the silicon photonics manufacturing and emerging as a global player. Uh, we all know that India has transformed from a large digital market into a global tech power over the last decade. Earlier, India was largely viewed as a vast consumer base for digital services and internet driven platforms. Today, the country is increasingly shaping its economy through digital public infrastructure, uh, some breakthrough innovation, startup ecosystems, UPI as we know. So, where does India fit into the global photonics and AI infrastructure ecosystems? And what opportunities do you see India is fit for research, innovation, and manufacturing?
Sure. I think India is in the best position to take advantage of photonics in general because we, not just as India, but many other countries in the world have difficult time catching up to what CMOS silicon technologies have grown. So practically Taiwan has monopoly in that domain. And it is very difficult to come up with a next generation fab there. But in photonics, that is a white space. And that also has a requirement of funding that is a fraction of the cost. It doesn't require us to build huge fabs, but we can do with relatively minimal OSATs and advanced packaging with the heterogeneous integration I was talking about and the fiber attach. A lot of surrounding industries can grow. In fact, we are working with many partners and trying to bring up that ecosystem here to make this into something more meaningful and much, much larger. And as India opportunities grow, this is not just a matter of consumption. We are currently importing $600 million worth of optical transceivers today for data centers, and data center market is growing 5x in the next few years can be expected. And we have to have all the local supply chain prepared to cater to these local needs and also build it for the world. And that is where I think India can move fast and take that advantage to be a global player in this, not just as a consumer of optical and photonic devices to build the next generation data centers, but also as a key manufacturer. So there are multiple areas in this ecosystem that have to come up. But I think we have a long list of things that we can make progress into, and we can capitalize on some of these unexplored areas with relatively less funding. And the listeners and any influencers who are listening to this definitely do partner with the right people. I think we can make internationally relevant technologies and products right out from India. And you talked about research and
Yes.
innovation also, right? And apart from manufacturing,
Yeah.
there are actually academic institutes, whether it is ISC, IITs, or there is a lot of academic research interest in photonics that is growing. Photonics beyond data centers, AI, and communication market could also be used in sensing. It could be used in quantum, and there is a lot of interesting applications that one could build around photonics, and that ecosystem of innovation is, I think, gaining some limelight. But again, that has a lot of potential, and we can actually build infrastructure to support and encourage those fields as well.
I agree with you, Rohin. And with the advancements that we have witnessed as a consumer in India, I mean, we can see that it is becoming an active contributor to the global AI ecosystem and tech development and innovation. And I think as AI models become more compute intensive and data driven, the technologies powering them, probably optical communication or the next generation semiconductor innovations, all of this will become very increasingly critical. And this creates a very unique opportunity for our country, India, to strengthen its position, not just through software expertise, but by also building some world-class capabilities in deep tech research or product innovation and advanced manufacturing. And I think the coming years could be very much transformative, especially as you highlighted, where, partnering up with the academia research or industry and startups, with again government initiatives and policies together can build a stronger innovation ecosystem.
No, absolutely, Priya. And this is something that we are looking forward to, and we are working closely with this ecosystem, and it
Right.
is coming up very fast. Uh,
Really.
and there is definite need for larger deployments and adoption. There are obviously technical challenges that need to be addressed, but overall, the ecosystem is coming up and the opportunities are becoming more and more visible. And I appreciate what you are doing to get this word out further for general public and influencers.
Thank you, Rohin. And that is what the ultimate agenda of our podcast is, to create awareness around these recent tech developments and innovations, and to make sure that the industry is aware and ready to embrace such emerging technologies, and ensure that we are leveling up in terms of becoming a leader in the global race of AI. Now, of course, with that being said, Rohin, I think when we talk about photonics, definitely it gives us a lot of advantages of being energy efficient, of helping us manage the high compute power. But I also feel that working with photonics is not without its challenges. There are several key obstacles. For example, the complexity of manufacturing, and other such challenges would are some of the bottlenecks when it comes to achieving those seamless integration with existing electronic systems. So, we want to know from you, Rohin, what are the biggest technical or commercial or any ecosystem challenges that is kind of becoming a hurdle for the widespread adoption of photonics?
I won't say it is necessarily affecting the widespread of adoption to begin with, but adoption does get affected by manufacturability. And one of the biggest challenges the industry is facing now, and big companies have announced delays in their manufacturing because of this. There are some fundamental physics level limitations that makes yield the cost effectiveness of the whole operation very sensitive to scale. So let me give you a simple example. The optical fiber that connects this data can have a core in which you have to inject light to 10 times thinner than the thickness of our hairs, right? So basically, you're talking about such small, accurate assemblies that are to be repeated at huge scale with very minimal tolerances or room for error, right? And we are in want of such advanced manufacturing facilities with inspection and testing. So all of those challenges do affect taking something from lab to mass production and wider adoption. Having said that, if you have the right partnerships and supply chain is well established around the world, we've been building that kind of partnerships, technology partnerships over the last 6 years, and we are still learning a lot of interesting things on ground in terms of the challenges. And all are actually culminating now into getting closer to commercialization. And as I was talking about, production readiness is something that all the industry wants for the future AI for the next decade, to be able to produce optical interconnects, whether it is near the chip or inside the chip or outside, connecting them between the racks or between the cities. All of that comes with the manufacturing level challenges, but at the research level, the fundamental physics still goes strong, and it gives us a lot of hope that there's much more room to scale the total data that we can transfer through photonics, and the power consumption reduction that we can achieve through the next generation advancements. So the future advancements will be inevitable, and we will also be able to successfully evolve into making some of these technology facilities and the ecosystem to build quantum communication and other technologies that are right adjacent to this. And I think with the right vision, right partnerships, with the right uh, backing in terms of the funding and other resources, we with I think most of these challenges can be addressed and will be addressed going forward.
It
Yeah, I
makes
hope that's
sense.
a comprehensive view, Priya,
Yeah,
from the industry perspective as to what is stopping us to
yeah.
just win huge markets, right?
No, definitely. And I think it highlights the overall, the challenging landscape, I would say, when it comes to advancing the technology itself. Because I believe it requires an entire ecosystem to evolve, simultaneously. You spoke about the manufacturing capabilities. Then we have supply chains. We also will face challenges in terms of talent development or investment, or even the entire industry-wide collaboration. And I
Absolutely.
think
And it's not as mature as the silicon semiconductor ecosystem. So it will
exactly.
take its time, but
Yes.
this is happening at much faster pace because the need is already established.
Right, right. And I think I completely agree with you that it's just that we need more collaborative efforts in terms of tackling the challenge front, I believe. And then we would be able to overcome the barriers. And I think then that will help organizations bridge these gaps and shape the next wave of innovation.
Absolutely. Absolutely.
Great. So, Rohin, with our entire conversation, we have focused upon photonics, silicon photonics, and what are some challenges. But one last question for you would be, do you think that the future of AI will be limited not by computing power, but by how fast and efficiently we can move data?
Absolutely. Like this is the biggest challenge, right? So it's not just about the compute and how fast you can compute, but it is going to be limited, and it is already limited to great extent by how fast you can move data between the processors. And this is limitation that I think will be addressed now. What you're seeing as connectivity between racks, between servers, is going to have photonics inside the box, inside the server, between the chips. And it is going to make the future data centers much more compact in their footprint. So basically, you will also be able to look at distributed architectures of data centers where you will see a lot more near edge and edge data centers, which are micro, small cloudlets that will be able to have that small footprint because of photonics integrated so deeply inside these boxes to make these compact distributed computing systems for the next generation. So it will be limited if we don't move actively and make strides into making these next generation systems happen. And there will be a lot of possibilities on these near edge systems where something can come up on your factory floor, rooftop, in your office spaces. That with such small footprints, data center per square foot area is premium. So you would want to ideally distribute across. And photonics has a key role in wider adoption of AI, not just in the hyperscalers, but also in the edge scenarios. And we believe that the latest innovations and the technology that is pushed by startups like us is going to play a massive role in this wider adoption of AI and high performance computing.
Right, Rohin. And I believe we are entering a critical window in the evolution of photonic computing with global demand for faster, greener, and more capable computing growing daily. Photonic systems offer an alternative that complements and in also some cases outpaces the traditional silicon based systems. And again, we spoke about silicon photonics also. It will become a very important part for the future of the entire semiconductor ecosystem, particularly in the AI driven environments where speed, bandwidth, and energy efficiency are critical. Thank you so much, Rohin, for taking all the time and effort to be on our podcast and giving insights and helping us understand that the current landscape and future prospects of photonics are promising. While acknowledging the challenges, the transformative potential of photonics is pretty much evident. So, thank you for your insights. It was a lovely chatting with you.
It was an absolute pleasure, and thanks for taking this deep, meaningful conversations to wider audience.
Thank you, Rohin. It's a pleasure. So, this is for our listeners. I hope you enjoyed today's discussion around how photonic driven future will enhance our digital infrastructure and pave the way for groundbreaking advancements in various domains. will be the future in the coming years. Stay tuned for our upcoming episodes, and you can view all our previous episodes on Spotify, YouTube, and SoundCloud. Thank you so much.